So overall ஒரு revision மாதிரி பண்ணிடலாம் யூனிட் 1. So embedded system. So embedded system it's a combination of hardware and software. So you are going to write a code and you are going to burn into the microprocessor. So microprocessor or a microcontroller, the ICs, so which you are going to burn. So that is nothing but your hardware, and the code you're writing the code, software code, in order to do the activities of the hardware. So what is the use of writing code? In the sense, in order to control the hardware, what to do. Okay, so you are giving the instruction in the form of different languages. So that is called a source code. So different languages, in the sense, it may be your C, C++, Java, embedded C. So whatever may be the language you are writing. Okay, so those are nothing but the soft codes. Okay, so here they given this definition. So system definition is nothing but a arrangement of different parts together in order to make a single function. Suppose if you are having a mobile having different sections, like for example, camera controlling one IC will be there, and micro phone will be there, and Wi-Fi for that separate ICs you have to use, and signal network in order to access the network from using the SIM. We may have different parts. So those are considered as a block. So for example, um, uh, if you take the network, so mobile communication, one block in your mobile, and the display projecting the output into the display, that is another block. And the microphones, those are nothing but the inputs, so that is the input block for sound. And what are the features are having in your phone other than that? So like sensors are there, so a lot of sensors are there. So these devices, everything will be controlled by single unit, so that is nothing but the processor. Okay, so here they given a system and they given an example as a calculator. And what is an embedded system? So embedded system, like I said, it's a combination of a computer hardware and software design for a specific function. So specific function means washing machine will do the washing purpose only. So we cannot use the same code or same processor to the another one. So another, for example, if you go for the AC having different code. So programming code will be different. So I'm going to design a system which is used for particular to do the particular task. Okay, so that is an embedded system. So they given an example: air conditioner, AC is one of the application, and biometric, oven, washing machine. In a plane and all, they will use for navigation purpose, radar purpose, and the angle. So you will find out the angle and which angle the plane is running. So everything will be measured using one of the embedded system. So combination of embedded system will be available in your aeroplane. Like if you see nowadays the car is coming with a lot of features. So everything will be displayed. You cannot go and check. Suppose the nowadays the car is showing the tire pressure. So how much pressure is available, whether you want to pump the air or not. Automated, everything is automated, and whether the any door is open means it is indicating to that display. So you can able to know. So that is the purpose of embedded system. Okay, not only the car, in your colleges and all, the printer, the scanner, the fax, so device, small devices, so where the ICs, the memory, so it may have a storage, then only we can able to store the programming. Okay, those are actually embedded system having the various of application, last application. Okay, and here they're just telling that the code and then processor, so how they are going to download. So you can able to see the applications like camera, game machines, electronic tablets, television, industry, and airline space, broadcasting, and for medical purpose they are using. So medical purpose not to show the UGC, EGC, the cardiac, what is the heartbeat. So you can able to see in some movies they may show a lot of display in the medical purpose in a hospital. And digital amusement machines, in the sense like a DJs and all, and producing different sounds and lights, everything. And printers, the car I told, so one of the application, mobile phones, smartphones, everywhere. And components, just main is one is the CPU, that is nothing but your processor, and the inputs which is taken from different sensor, and the output which is nothing but the display will be output, the motor will be output, and the relay. So motor in the sense not to move it. Um, for example, you're having a robot. Okay, so robot have to move. So how it will move based upon the rotation of the motor which will be fixed inside, so that it will move front back front back. The leg will be move like front and back, so that the motor will move upward direction, I mean clockwise direction and anti-clockwise direction. So based upon that it will move. And the input in your robot, what are the inputs will be there? So maybe it may be having a camera, so that it can able to walk. Otherwise some sensors, obstacle detection sensors, whether any obstacle is there means it will turn in another direction. So for that they will use the ultrasonic sensor, PIR sensor, different sensors. So these are the components. And so what are the components are available here? So basic is a processor will be there, and memory should be there surely. Why? Because we are going to write a code, and like I said, input units will be there, output unit will be there, and network unit is an optional. So network in the sense inside the processor, network has to be done. Why? Because the processor has to communicate between the input output ports, between the memories, etc. And if you want to control remotely, in the sense I want a like a LAN, WAN, so wherever I want to access, whether I want to access within a building, I will use a WAN connection. Whether I want to access um, within a same room, in the sense I will use LAN connection likewise. Okay, and then operating system. So operating system is nothing but the software which you are going to write. And same thing they represent here with example. Classifications are small scale, medium scale, sophisticated embedded system. So like I said, a small scale, they will use a 8-bit microprocessor, and not more than that, and the memory size will be very small. It will do small tasks. So for example, the biometric, those are small scale embedded system. And if you go for the medium scale embedded system, they may use a 32-bit or 16-bit or 32-bit processors. So and if you go for the sophisticated embedded system, so sophisticated means a huge for a high-end application like a satellite and all, they will use so separate embedded system. Why? Because if you take a washing machine, so they will production will be in terms of 1,000 or 1 lakh or 2 lakh. They will product make a same product, but satellite and all very few. So if they are going to send a satellite for weather condition means they want to prepare only one, so not more than that. So those are comes under the sophisticated embedded system. And the component which we are going to see here, uh, these are the basic components. So surely it has to be the, so inside the processor the power supply should be there not to provide the proper power supply, and oscillation circuits to provide the frequency of oscillation. It represents the speed of operation. And the processor, so main is a processor, and we have to give a timer circuit, so not to give you a particular timings to complete a specific task. For example, if I'm cooking anything, in the sense I will set a mode 10 minutes, so that it require the timing devices, so that's why the timer is required. And interrupt controller, so interrupt controller in the sense while cooking I am giving the inputs, so those are nothing but the interrupt. I am interrupting this processor and giving my input. I am stopping the program which is running, so I am giving a new input. So those can be controlled by interrupt controller. um, One more example for interrupt controller is like a ATM. So ATM will keep on display something. So when we inserted our debit card, it will change to another mode. So okay, so that is nothing but a interrupt. And output interfacing device and input interfacing device. So surely for an embedded system, there will be output and there will be input. Okay, it's a mandatory one. And the memories. So memory not to write the program. So and as well as not to access the data. So we require the program memory and the data memory. And next is for communication purpose, we may use a serial communication or a parallel communications. And system application specific circuit. So for what is the system application specific circuit? In the sense, suppose I am calculating any temperature, means I want a temperature sensor. Suppose I'm calculating the humidity, means I will change the humidity sensor. So for a specific application, I require a small separate circuit. Okay. So these are the building blocks of embedded system. I'll just go through it. We will study one by one. So first, now to select the processor based upon the application, we need to select. Suppose I'm going for a small scale, it's enough for me to do in using a 8-bit. Suppose I want to do a very big embedded system. I'm going to design a big embedded system, means I want to select whether 16-bit or 32 bits based upon our requirement. Okay, so that's why they're selecting the processor. And so while selecting the processor, we need to go through the instruction set, how to write the instruction set. Like you studied already in MPMC, right? The instruction set you studied. Guys,
Yes,
you are
sir.
there? Yeah.
Yes, sir.
So each and every processor having different instruction set. And what are the processor you studied in microprocessor, MPMC?
8051.
Okay. 8051 is microcontroller. And then what about MP, microprocessor? You were talking about MC, microcontroller. 8051 is a microcontroller. What about MP, microprocessor? Which series you studied? Number you didn't remember?
No, sir.
No, it's 8086, 8085. 8085 you studied, na?
Yes, sir.
8085 and 8086. 8085 is a 8-bit processor and 8086 is 16-bit processor. Okay. So if you go through that one again, just take your MPMC notes and check it. The instruction set will be vary. Why? Because if you take a 8085, it they may use only 8-bit data and 8-bit operation. Everything will be. If you go for the 8086, it will be 16-bit. So surely the instruction set will be vary. The mnemonics will be vary. So we have to go through those things and all. And what is the maximum bit I'm going to use? Whether it may be a 8-bit or 16-bit likewise. And what is the clock frequency? So those are the things we need to check it out. And already I told the build process how to make a code. So this is the hierarchy. So how, in the sense, first I'm going to write the C program. It may be a C or a Java, whatever may be. So there is a source code. So source code is nothing but the program which will be written by the human being. Okay, and compiler is there in order to convert that into assembly language program. And after that assembly language program will be given to assembler in order to convert it to machine language program. Thing is, the machine language code is used to understood by the machines. So we are writing in a C program like a printf, scanf. So that can be understood by ourselves. But machine can't understand that A, B, C, Ds and all. So a machine will work. I mean, the machine in the sense the processor. The processor able to know about the ones and zeros. So the coding, so one and zeros coding only it should be under. So that's why we will convert that into the machine language coding. Okay, and in a linker there will be a multiple object. So object is nothing but the machine language model. So multiple object in the sense I told that in embedded system not only the one processor will work, it will work with the multiple processor also sometimes based upon the application. Like ATM. So I told already. So ATM having multiple processor. So one processor will do one task, like it will read the card details and all. It will access with that network and then it will provide the authentication. And another embedded processor will used for counting the money. So for counting purpose, and it will count for 2 to 3 times in order to make it sure the count is exactly same which you given by you. Okay. And another processor will used for dispatching purpose. So for dispatching, it will take the money from that and it will open the uh, port to give the money. So after you taken the money, it will automatically close down. So likewise, multiple processor will work. Okay, so that's why here linker used to connect with multiple objects. Why? Because suppose if code is read by the processor, in the sense next to process, it has to ask you how much money you want and type the password like that. So there will be a link. So once completed the authentication, next it will go to how much money. Once you given the money, and it will take the money and it will start to count. So once everything completed, and we'll go back to the main menu. So okay, so surely it requires some link. So we use the linker not to compile, not to combine all the object file. So after that, that will be given to your loader. So loader is used to load that into memory. Okay. And the design process, simply I will tell. So design process is used to design a member system. So how, in the sense I told, like a calculator. So take a calculator. I'm going to design a calculator. What are the inputs I require? What are the outputs I want to provide? What processor I want to use, and how much memory it requires, and what are the operation I want to do. So likewise, I will take the specifications and so here they given the design processor. So development process and model analysis and design. So design, they are using the architecture and implementation of design and testing purpose. So first one is development process. I'm developing the basic requirement and all, and that requirement of a system. So what are the requirement I needed, that will be put in the first step. Second is design architecture. So what is the design architecture? In the sense, based upon the requirement, I will write the code. After writing the code, what are the hardwares required, and how it should be likewise. So next is a implementation. So after once everything made by the paper, after that I will go for implementation. Implementation in the sense practically I'm going to do using the hardware. So that is nothing but an implementation. Once it is completed, I want to test. Why? Because it is working perfectly or not. So that is the last one. And so like this is the same thing. So requirement, specification, architecture, and what are the components, and then system integrator, in the sense the final product. So it may be done from top down design or bottom up design. And structural units in embedded system, like we seen already the structural units. If you go through this, so these are the main blocks. So what are the structures is there inside the processor? So this is the structure which is available inside the processor. Like instruction queue will be there, instruction register, and the ALU, arithmetic and logic units. So like this, lot of blocks are available which is used for doing the specific task. And let me explain shortly. So internal buses used to communicate the data as well as the program instruction set, and the address bus used to carry the addresses. Data bus used to carry the data, and control bus used to carry the control signals like read operation, write operation, and stop operation, wait, halt, etc. Those things and that. And bus interface unit is used for suppose only one bus will be there. Whether I want to use that bus as a data or a address bus. So for that. Now to give the access, I require the bus interfacing unit, and memory address registers used to hold the addresses, and similarly memory data register is used to hold the data, so where the data is stored, and program counter which used to hold the next instruction address, so that easily the processor will execute continuously instead of waiting where the program is available. Likewise, why? Because if you are writing the code move ax comma bx, so it may take 3 byte. After that, another next instruction will be stored after the fourth bit. So likewise, the count will be counted by the program counter, so that easily I can know that once one instruction I completed, I know the memory location of next instruction that will be available inside the program counter. And stack pointer, the address of the last stacked point, it will be stored. And instruction register used for instruction code execution unit of the processor, and similarly the instruction decoder. So instruction code you will write in the mnemonics, that will be decode using the instruction decoder, which will be understood by the machine, I mean the processor. And instruction queue is used to store the, I mean buffer, make it buffer readily available, so that easily I can able to access instead of I want to read from the memory. In the sense, it may take some time. So listen, microprocessor is very fastly working. So if it is taking 1 second also, it's a delay. It actually it will works on in terms of microseconds. Okay, you can't able to imagine so that much fastly it will work. So that in order to not to wait, I will use the instruction queue so that in that queue the instruction will be waiting. So readily it will be available. So if it want to fetch from the memory, in the sense it has to go to the access. After that, it will get fetched from the memory. It has to take to from memory to the processor. Instead of that, directly it will connect to the instruction queue. And arithmetic and logic unit. So this you know. So in order to perform the addition, subtraction, and multiplication, and logical operation like and or function and function, etc. So that will be completed by ALU unit. And floating point processing unit. I told that and logic unit will do the binary value. Does not have any decimal value. So for example, binary value is nothing but I am taking it 2. So 2 equivalent value is 10. Suppose I want to do the operation with a 2.2, so that the ALU cannot able to operate. So on the time I will use the another processing unit, that is floating point processing unit, in order to perform this number which is having the decimal point like a 2.2, 1.3 likewise. So for that, in order to store the, I require the one register. That is for processing, another is for register. So that floating point register set is required in order to store the value. And control unit, it will control all the bus activities and the functions of each and every device which is available in the microprocessor. And memory management unit, which used to manage the the instruction where it has to write. So it will manage the memory. And then application register set is there. So it is a set of on-chip register used during processing the instruction of an application program of user. So what it represents the sense, the user. So in ATM, I am giving the input using the keeper. So those are nothing but application applicant. So we are the applicant which is giving the input. So those kind of input will be stored in the application register set. And the instruction catch is used to store the the first in first out, like queue. So queue, it will works under first in first out, so those will be stored in your instruction catch. And data catch used for storing the data. Okay. And prefetch control unit used to control the instruction catch as well as the data catch. And register window, so it's used to store the static variable and the status word. So static variable in the sense, like I said, the pi. So pi's are constant. Okay, so that kind of variables will be stored in your register window, as well as the status word. So status in the sense whether it is a overflow flag is available, or whether it is a zero, whether your result is negative or a positive. So everything will be stored in your register window. And advanced processing unit, so it will be used for a multi-stage pipelining processor. So pipelining means executing the instruction, multiple instruction at a cycle. Okay, so that is one. And atomic operation unit is another one. So in a pipeline, actually, in a first cycle it will execute the fetching of a first instruction. In second cycle it will decode the first instruction, as well as it will fetch the second instruction. But if you go for the atomic operation unit, simultaneously it will do the operation. Okay, so this is your structural unit. So this is the important one. So structural unit in embedded processor. Okay, so surely you may get a question. And next is we will go to selection of processor. Like already we've seen how to select, and whether it is working in pipelining or superscaling architecture, and what are the catches, and how the memory, the speed of memory. So, and you are going to use the RISC architecture or CISC architecture. So RISC in the sense a reduced instruction set, and CISC is complex instruction set. So reduced instruction set, it will be like easiest method. If you Is just in the sense I can able to do a big operation in a single instruction. If you go for the complex, for doing a only one task, I have to write 4 to 5 lines of your code. So that is the difference between the RISC and CISC. RISC means a reduced instruction set. I reduce the number of instruction which I am going to complete a one task. Okay. And like a register window we already seen, and auto shutdown feature is used to suppose if it is not working in the sense, I mean idle mode in the sense, so automatically it will shut down. And burst mode in the sense sending the data in huge manner, so that is a burst mode, access external memory faster. And what are the memories? Already we discussed the types of memory: internal ROM, EPROMs, everything. I think you already know about it, and I don't want to discuss again this way because it's very easiest one. Mm, direct memory access. So I will tell what is the direct memory access. So we may have only 20 minutes remaining. So direct memory access is used to uh, access the memory from the input output devices without any interface from the CPU, so that I can able to do simultaneously. CPU will work separately, and similarly the input output device, if that wants to access the memory, or memory want to access, I mean read from the input output devices, in the sense I will use the DMA in order to control. So what is the main operation means, the if any wait, let me show this diagram and it will be easily understood. Yeah, here. So processor is there, in down DMA is there, and port is there. So ports are connected to the devices. So in a port, first it will request, I want to write or I want to access some data from the RAM. So it will give the instruction to the DMA controller using DMA request. So can you able to see the DMA request in down? Guys, you are there?
Yes, sir.
Okay. So here DMA is requesting first. So after that, that request will be given to the processor. So why, in the sense I want to access the bus, so I am asking the permission to the processor, so that the signal is nothing but bus hold request. I'm going to access the bus. So you just hold it. You don't do any operation on the bus. I will use it. So it will give the request. Once the processor accepted, it will give the acknowledgement. So that is bus available acknowledgements. Okay, now bus is available. You can able to utilize for communication the input output to your RAM. So that after it receiving, it will send the acknowledgement to the input output ports, so that the bus is disconnected from the CPU. It will go to the third state, that is high impedance state. In the sense, it is not connected to 0 or it is not connected to 1. So that what will happen? The ports will be access the RAM. So whether it wants to write or it wants to read, it will do. Okay, so this is the operation will be done in your DMA. So direct memory access. And memory management method. So here I told about how the memory will be. So based upon the RAM and ROM. So virtual address will be the physical address will be the. So physical address, I told an example like in a book. So there will be page numbers. So that is nothing but your physical address. And the virtual address means I will give the subdivision. Suppose first chapter means in that I will give 1.1, 1.2. So those are nothing but the subdivision. So virtually I am assigning some numbers in order to easily access. But physical address is like page number, book page number. So each and every page having a number. Okay. And if it comes to the processor, in your memory, address is starting with 0000, 0001, likewise, etc. And if you go for the virtual address, I will make a segment and I will name it some other, for example, block 1, block 2, block 3. So in your block 1, the address will be, suppose it is a 1 MB, it will be available from 00000 to your 1024 byte. Okay, so that is nothing but your 1 MB. So, but here I will represent it as a block. So I'm representing a block that is nothing but virtual address. So physical address means I will write like 00000001. So those are nothing but your physical address. So next is a memory management unit. So how to allocate and deallocate, and the swapping and paging. So swapping paging is, I told, suppose the main memory is full, I can't able to do any operation. So further, if any task is assigned means, I will use the secondary memory. So secondary main memory is nothing but the RAM, which is available inside the processor, and secondary memory is nothing but the hard disk, which I'm connecting externally. So I will take that hard disk memory, then I will assign, and then I will do some task. But thing is, the main memory is very fastest one when compared to your secondary memory. So the task which is assigned to do from which with from secondary memory will take some time. The delay will be there surely. Okay. And here the two techniques are there. One is a paging, another is segmentation. So paging, I told, if you're dividing a memory with the space same size, so that is nothing but your paging. If you're dividing a memory in different size, that is nothing but your segmentation. So these are the two different techniques which using in memory management unit. And allocating and deallocating processor. So allocating means suppose any task is asked to perform, I will give them RAM. So if it requires 10 MB, in the sense I will assign the 10 MB. After once the task is completed, I will take that memory back, so that I won't give that to that one. So if any other task is available means, I will provide the size. So how much RAM it requires. So based upon that, I will provide the memory space. So those are nothing but allocating and deallocating. And tracking the memory use, in the sense, in order to know how much memory is free, how much memory one application is occupied, so that we can able to know. Suppose some application drawing more memory, I will block it. Unwanted tasks, I will block it. Okay. So user memory space is nothing but the program user where they are storing the data. Okay. And so segmentation, like I said, so it's also dividing a memory into a different size. So they will be segmented like a core segment, data segment, block started by symbol, and stack segment and heap segment. So code segment is nothing but the code which I'm going to write. So I will make it available only for the program. So likewise, if it is data means, I will provide some memory for the data. So likewise, I will provide the remaining also. And so these are very easy, like a first fit, next fit, best fit, worst fit, quick fit. So first fit means I will start with the beginning, and next means once I started from the beginning, next space, so I will allocate something. So that is nothing but your next fit. And best fit is nothing but I will scan the entire list and where it will be fixed properly. So why? Because sometimes some memory will be occupied in between. So if, for example, you are inserting a pen drive, you are putting a lot of files. Okay, so I have just for the namesake, 1 to 5 files you are writing on your pen drive. So after that, you are deleting the third one. So initially, what it will do, it will save from 0. So from the beginning. So you deleted the third one. So that memory will be deleted. And suppose I am putting the another one, sixth file, which is having a huge file, huge one. So what it will do, it will split. So it will split, and how much it will store, that much memory will be stored in the which I deleted last time. So third file I deleted, right? So it's, for example, it take 1 MB means, and the file which I'm loading now is 3 MB means the 1 MB will be stored in that the existing one, and remaining 3 will be stored after that. Okay, so likewise it will delete in between also. So best fit means, so without splitting it, if I want to store any data in sequential manner, I will search the entire one. After that I will store. So I won't bother about the some memory space which is not used in between also. Why? Because the size is very less. The file which you are going to load in the pen drive is large, so that is a best fit. And worst fit, I told, so wherever the memory space is unallocated, I will store. For example, 10 MB size of a file I am loading, the sense 1 MB I will store in first memory location, and I am searching for next I am storing in the next one. So likewise. And quick fist is suddenly So initially I won't carry an entire one, just simply I will store. Okay. And timer and counter. So simply I will tell. So timer is to provide the clock cycle based upon the counter. So counter is used to count, for example, one task in how many clock cycle it is completing. So and based upon the clock cycle, I will calculate the timings. Okay, and you already using the timer and counter in the TVs and all. You're keeping the timer, and as well as the AC, you're keeping the timer. So wherever the embedded system is there, surely the timer will be there, and even in your ATM also there will be a timer. So for a particular duration, if you're not accessing anything, you're not giving any input in the sense, surely it will change. So you can't able to do further transaction. So it will end the process. So those are the function of the timer. So these are the states, and watchdog timer I told already. So any task is not opening, so it will open for infinite loops. So for one day it will continue keep on trying to open. So in order to stop that, I'm introducing a watchdog timer. So suppose a task is not opening for particular duration, it will show a error message whether I want to wait or I want to close. So that will be available in your mobile phones also. If any application not opening, it will show a error message whether I want to wait or I want to stop, so that I will report it. Okay, so that purpose I'm using the watchdog timer. And real-time clock. So real-time clock is used to implement the normal clock, so which is having the 60 minutes, the seconds, everything. Timer is different. Real-time clock is different. Okay. So in circuit emulator, simply I will tell within a definition. So I'm going to debug. I'm going to run the, replace the processor by adding the another circuit. So I'm not going to use, I'm going to use the different processor, another processor. I'm going to run the program. So nothing but in circuit emulator. Can you hear me?
Yes, sir. Yes, sir.
Okay. And the last one is target hardware debugging. So I completed the embedded system. Now I want to check the entire process. So what I will do, I will connect that embedded system to your laptop or a CPU, and that is nothing but your laptop or CPU is nothing but the host, and the embedded system which you are connecting, that is your target. Suppose I am checking the biometric in the sense, biometric is nothing but the target, and I will connect to the computer. I will check. So computer is nothing but a host. So I will give the input manually. So using the keyboards, and I will check whether it is working fine, whether any error is there, whether any delay is there, whether I want to change the program. So like this, I will keep on checking. So for that purpose, not to debug the hardware, I'm using this one. Okay. So that is the last one. Any clarification is there? Any doubt? Any queries?
No, sir.
Okay. So how many of you present?